Yesterday morning didn't go well. Oh man, work, what a mess. It sucks. On to more fun things. So I have rolled back my progress in this free code camp tutorial that I've been going through to the beginning of the current lesson that I was on, just for some cohesion, some continuity purposes for the videos that I'm uploading, I suppose. Um, but I do want to recap kind of what I've learned up to now. But I'm going to start with the deletion of this fund me stuff so far. So give me one sec. All right. So what we've learned so far is we've created this simple storage contract. We've learned how to deploy it onto the blockchain, which is done here. Let me get rid of this. So effectively, all this does is it allows you to store basic data and map it to retrievable other variables. So like we deploy this and you can see we've got an add person function which takes a favorite number. So we can put like 54 equals bam, transaction completed. And then we can this I don't think these two are linked, so like we can store a random favorite number like 80 and then retrieve it here, right? But if we want to recall what my favorite number is, we've got this function here, which will recall it, right? This, I believe, retrieves the index of the array that we created. So like if we put index 0, it should return me, and it does, and my favorite number. Retrieve, what does this? Okay, retrieve, just same thing as favorite number. So as you can see, it just enters data into the blockchain and allows you to retrieve pretty basic stuff. Basic stuff. Favorite string. You're gonna see a lot of stuff like this. Um, okay, now beyond that, we've taken one step further and created a storage factory, which basically just is an exercise in inheritance and referencing and creating contracts within contracts. So nesting in that regard. So if we deploy the storage contract, see there's a bunch more stuff we can do, but there's a lot of things that we've seen in our previous contract, right? Add person, favorite number, name to favorite number, people retrieve. Those are all functions of this initial contract and are inherited by the storage factory as a product of this. So you can create a contract is of type this contract, um, which exists as a product of importing this sol file or the contract there. So other than that, the functions are basically the same. So it inherits the ability to store and retrieve that data, same as the original contract, but it also has the ability to create a storage contract. Um, so like you can create this, and then if I recall, this returns the address of the storage contract that you've created, which you could then reference to, you know, perform these functions were that it coded that way. Anyway, that's kind of the brief, high level. I barely understand recap of everything I've done so far, and now we're learning this fund me contract, uh, which is going to be more transactional from my understanding. But I did 10 or 15 minutes of it, and Yeah, my eyes crossed at some point. So
The GitHub repository associated with this course also has all the code for this lesson. So let's jump into it. So we're back in Remix now, and we're going to go to contracts, and same as before, we're going to create a new file. We're going to call this fundme.sol. Now, same as last time, we're actually going to add this SPDX license identifier, MIT right at the top, and then we're going to choose our Solidity version. So we're going to go pragma, Solidity, and for this, we're just going to do greater than or equals to 0.6.6 and less than 0.9.0. And great. This should look pretty familiar. Now, we're going to do contract fundme, and we're going to start working. So what again do we want this contract to do? We want this contract to be able to accept some type of payment. So let's create a new function that can accept payment. We'll call it fund. So we'll do function fund public, and we'll add a new keyword in here called payable. When we define a function as payable, we're saying, hey, this function can be used to pay for things. When you call a function, every single function call has an associated value with it. Whenever you make a transaction, you can always append a value. This value is how much way or gwei or finny or ether you're going to send with your function call or your transaction. As we mentioned before, way, gwei, and ether are just different ways to talk about how much ether you're going to send. So if we look at a way to Ethereum converter, 1 ETH is this much way. 1 way is the smallest denomination of ether. You can't break up Ethereum into anything smaller than 1 way. This is why when you're talking about how much something costs, everything always defaults to way, or the smallest unit of measure in Ethereum. So again, for us to test, we're going to stick with the JavaScript VM for now. If we hit deploy, we get a new contract, and this button is now red. It's red because it is a payable function. So now if I hit this fund button, I can add a value associated with it. So what do we want to do with this funding? What do we want to do when people send us something? Well, let's keep track of who sent us some funding. So what we can do is we can create a new mapping between addresses and value. So let's do a mapping of address to uint256, which will represent the value. We'll make this a public mapping, and we'll call it address to amount funded. Now, in this fund function, let's keep track of all the people who sent us money, or all the addresses that sent us some value. To do this, we can use some keywords that go along with every transaction. So we'll say address to amount funded of message.sender equals or plus equals message.value. Message.sender and message.value are keywords in every contract call and every transaction. Message.sender is the sender of the function call, and message.value is how much they sent. So whenever we call fund now, somebody can send some value because it's payable, and we're going to save everything in this address to amount funded mapping. So if we deploy this now in our JavaScript VM, we now have, again, a new view function called address to amount funded, and we can even hit the drop down to see the full name. Now, if I hit fund, nothing's going to happen, right? Because my address is going to be sending 0. In order for me to send something, I have to add some value along with my transaction. So let's send, for example, 1 gwei, which is going to be equal to 1, 2, 3, 4, 5, 6, 7, 8, 9, this much way. So before I hit fund here, if I copy this fake account, which is up here, and I put it in this address to amount funded, it's going to return 0. But now, if I add 1, 2, 3, 4, 5, 6, 7, 8, 9 in here, and we go ahead and hit fund now, we've now just called this fund function with a value of 1 gwei associated with it. So if I call this address to amount funded now with the same address, I can now see how much we've funded this smart contract.
Okay, so I believe it was this. I kind of missed it. I think this is the address we're supposed to fund. So 1GUI fund. What? That didn't work. Address to amount funded. Okay, it has to be this address then. And then it funds the contract. So if I go 1GUI fund, I should be able to call. Oh, there's two for some reason. All right.
And we can even add more GUI. We'll add 11 GUI, for example. We'll call fund. And if we call this now, we can see that even more has been added. When we send our funds to a contract, this actually means that this contract, wherever this is deployed, now is the owner of this amount of Ether. So this is fantastic. We now have a way to fund our smart contracts. Now, here's the thing. In this smart contract, in this funding that we're doing, we want to create a minimum value for people to be able to fund our endeavors, which, whatever they may be. We want to set some minimum value here. And Ether is great, but for whatever reason, we want to work in USD. Or maybe we want to work in some other token. So how are we going to get the conversion rate from that currency to a currency that we can use in this smart contract? Well, the first thing that we're going to need to do to set this value is we're going to need to know what the ETH to USD conversion rate is. Because if I want to accept Ethereum as the token, but I want it in its USD currency, well, then I'm going to need to know what that conversion rate is. So how are we going to get this data into our smart contract? Where are we going to get this data from? Now, remember how we talked about blockchains being deterministic systems and oracles being the bridge between blockchains and the real world? Well, this is exactly where oracles come in. When we're talking about these systems, these blockchains, they can't connect to real world events. They can't connect to external systems. They can't do external computation. They're intentionally these deterministic systems, these walled gardens. So in order for us to make this connection, we need a blockchain oracle. We need some type of network here. Now, just to get a little bit more technical for you, if we look at a blockchain can easily say 1 + 1 = 2, and every other node can easily verify this. However, a blockchain can't easily say, okay, let's all grab the same random number, because each node is going to get a different random number. They also can't say, hey, let's make an API call, because if one node calls the API at a different time, another node calls it, or specifically like an HTTP GET, there could potentially get very, very different results. And if another node tries to replay these transactions by calling these APIs again, maybe 10 years in the future, there's a good chance that that API is going to be depreciated. And they could be hacked, they could be malicious, etc., etc. The other reason that blockchains intentionally can't make API calls is because then they would be making assumptions about the real world. And layer ones typically don't want to have an opinion on any political or geopolitical issue, whereas an oracle network, on the other hand, can make those assumptions. The other main thing we need to talk about here is centralized oracles being main points of failures. If you or I say, hey, I'm just going to be the oracle, I'm going to be the one to put this data on chain, we now have this massive centralized point of failure. We've done all this work to make our decentralized computation decentralized and on-chain, but we ruin all the decentrality by having a single point of failure. Remember, one of the whole purposes of blockchain is so that not a single entity can flip a switch and restrict our freedom to interact. With a centralized oracle, a single entity can flip a switch and restrict our freedom to interact with each other. We also need to get data from many different decentralized sources or do any type of computation in a decentralized manner. This is where Chainlink really shines. Chainlink is a modular, decentralized Oracle infrastructure and Oracle network that allows us to get data and do external computation in a highly Sybil-resistant, decentralized manner. It can be as customizable as you want, as you can run with one node or many nodes, or do as many nodes as you like. Now, currently, one of the most popular features of Chainlink is their data feeds or their price feeds. We can even go check them out over at data.chain.link. We can see a number of different price feeds and the networks that are providing the prices for these specific pricing products. We can see here by looking at the UI, there's a whole number of decentralized different oracles returning data for different price feeds. This one, for example, is ETHUSD, and it's also exactly the price feed that we're looking for. Having a decentralized network bring this data on chain and have it as a reference point of definitive truth allows users to all collaborate and use this common good, and it will be cheaper, more secure, more efficient than anybody even running their own centralized oracle. So these price feeds are incredibly powerful. Additionally, they're being used by some of the top protocols in the DeFi system right now, like Synthetics, which at the time of recording is securing around $2 billion. SushiSwap for leveraging trades, Set Protocol, Commodity Money, Aave for understanding the price of an underlying collateral. Now, this is an example of an out-of-the-box decentralized solution that's already been packaged in a decentralized manner for you to consume and for you to use. This makes going to production 1,000 times easier than building everything yourself. However, if you want to make API calls and build your own decentralized network, you absolutely can with the Chainlink API calls. We're not going to go into that here because using the Chainlink price feeds, Chainlink VRF, Keeper Network, and all these other pre-box decentralized services are going to make going live and going mainnet a lot easier. You can always make a Chainlink HTTP GET call as well. We're not going to go over this though because putting this into production is a little bit trickier, and working with Chainlink VRF, if you ever want to try them out by themselves, you can always head over to docs.chain.link and head over to get the latest price feed. There's usually a remix button actually that we can click, and it will kick us out to a remix edition with all the code already ready to go for us. If we just hit this gist right here, this will include all of our code, which we'll go into in a second. But let's go ahead and compile it. We're going to deploy it to a real network here. This one looks like it's actually for Kovan, so we're going to go ahead and switch to Kovan. Looks like I don't have any Kovan Ethereum, so we're going to grab Kovan faucet. We can usually find different faucets in the Chainlink documentation.
This is all covered earlier when you're getting
there is a Kovan faucet.
testnet funding through some of the faucets.
It looks like in order for us to get some Kovan Ethereum here, we have to log in with GitHub. Then we can add our address in here and get the Ethereum. In the interest of time, I'm going to skip ahead from me doing that.
I have a little bit of ETH on
Great, it looks like I've got some Kovan testnet now. Being able to switch between testnets is going to make you a lot more effective as an engineer as well, because you're going to be able to understand how each network actually works. So now we've compiled this. Let's deploy this. Again, MetaMask is going to pop up. And let's go ahead and click the get the latest price, and we can see that this function does indeed return the latest price of Ethereum. Now you might be asking, why does this number look so big? Well, remember how we talked about Wei and Gwei and Ether? Well, the reason that those exist is because decimals don't work in Solidity. So we actually have to return a value that's multiplied by 10 to some number. So this value is actually 2,614.
If only it were that easy to get ETH in the real
10
world.
raised to the 8th. Now, the next question you might ask is, well, why did we work with this on a testnet? Why couldn't we do this on a local network? And the answer to this is because there is a network of nodes looking at this testnet and delivering data onto this testnet. When you spin up a local network or do a simulated VM, there are no nodes actually doing that. We'll learn later how to actually mock these interactions and mock a Chainlink node returning data onto our blockchain. But for now, let's head back over to the contract that we're working on so we can learn how to implement this in any contract that we ever want to. Another contract called, in this case called price feed, has a function called latest round data, which returns a lot of data. It returns a round ID, which defines how many times this price feed has been updated. It returns a price, which is the actual conversion rate between the two assets. It returns a started at, which defines when this was last updated. it returns a timestamp, and it returns an answered in round. Don't worry about answered in round for now. If you want to dive a little bit deeper into what these rounds mean and what answered in round means, you can definitely check out the Chainlink documentation and some of the FAQs to learn more. Now, how do we implement this data feed into our FundMe application? Well, the first thing we're actually going to need to do is we're going to need to import the Chainlink code. So we're going to do import at Chainlink/contracts /source /v0.6 /interfaces /aggregator.
Oh, I'm much worse than this guy is.
Interface.sol. Now let's talk about what this is actually doing. Oops, looks like I spelled aggregator v3 interface wrong. All right, great. Now it's actually compiling. So let's talk about what imports actually do.
That's all. Oh, what's going on? Oh, of course. Okay, so to kind of recap what this guy just did, since it's the second time I did it, he kind of blew through it quite quickly. This is importing the aggregator v3 interface directory from the Chainlink GitHub repository. So it's literally just giving us access to these functions. So it anyway, he'll likely go over it here with some depth, of course, but it's giving us access to these so that our FundMe is able to pull this answer as an accurate data regarding the ETH to USD conversion, right? So I've already got this up. This is the Rinkeby testnet, and these are the addresses to those data feeds. And this is the ETH to USD conversion. So ultimately what we're going to be doing here is implementing this to view that data feed, and then that data feed is going to output what the value of Ethereum is, and then we perform a conversion into USD. So, or rather, it outputs the value of Ethereum in USD. I should say.
As we know, an import will take whatever code you're importing and stick it at the top of your project. So when we import from @chainlink/contracts, we're actually importing from the @chainlink/contracts npm package. We can look up @chainlink/contracts in npm, and we can see and read more about this repository. This links us back to the GitHub, which will tell us a little bit more about what's really going on. If we follow that import path that we got from the documentation, we'll end up on this file. In front of me now, we have what's called an interface. You can see these contracts don't start with the contract keyword, but they start with the interface keyword. They have the exact same pragma Solidity at the top, but the main difference is that you can see that their functions aren't completed. They just have the function name and its return type. Now, just to be a little bit more explicit here, I'm actually going to go ahead and delete this import statement on the top and replace it with that interface code from GitHub, just to show you exactly what's going on. However, if you've already typed that @import syntax, feel free to leave it in there. And just remember that it's going to be the exact same as me copy pasting the interface code in. In our code here, Solidity doesn't natively understand how to interact with another contract. We have to tell Solidity what functions can be called on another contract. This is where interfaces are actually going to come in. Similar to structs, what we can do with interfaces is define a new type. So if we copy all this code from this section and place it at the top of our code here, above where we're declaring a contract, we can actually then interact with contracts that have these functions. If we go ahead and even compile this, we can see that this does indeed compile correctly. Remember how we said before, we talked a little bit about ABIs. Well, interfaces actually compile down to what's called the ABI, or the Application Binary Interface. The Application Binary Interface tells Solidity what functions can be called on another contract. We need Solidity to know what functions it can use and what functions it can call other contracts with. And if that was a little bit confusing, just know anytime you're going to interact with another contract in Solidity or smart contract programming in general, you're going to need that contract's ABI. We'll go into what these ABIs look like a little bit later. Anyways, to simplify it, interface compiles down to an ABI.
So to kind of roll back to our simple storage factory, that kind of makes sense, right? Because we had, one second, I'm just going to deploy one here. When we had created this, or I should say when we first deployed this and we had added, whatever as a person here, this is adding it to the people array contained within the storage factory contract. This isn't actually adding it or interacting in any way with the simple storage factory or the simple storage contract, right? So while the storage factory is able to create these contracts, none of the other functions within this are actually interacting with that contract, right? Because it's not, neither of them have an interface. There's no ABI. So the only exception is this last call function here, which will print out the address of the simple contract that we created, right? But that's because we add that to an array as it's created here to be called. So that all makes sense then. We needed to make this a simple storage of its own. We needed to make the storage factory a simple storage of its own because we didn't have an interface in play to be able to just call directly functions of the contracts that we were creating. So the next step to implement an interface here would be it would allow us to create a simple contract and then add people and call from that contract's address. All right.
We always need an ABI to interact with a contract. So how do we actually work with this contract here? To interact with an interface contract, it's going to work the exact same way as interacting with a struct or a variable. Let's define a new function called getVersion, and we're going to call this version function on this other contract. So we'll start out doing function getVersion public. Remember, it needs to be a view since we're just going to be reading this state, and even in the interface, it even defines it as a view returns. So we'll even grab this whole bit right here, view returns uint256. Now, the exact same way we define variables and structs, we define working with other contracts and interfaces. So the first thing is we name the type, which in this case is aggregator v3 interface. Then we'd name the visibility. But since, again, we're inside of this contract, we're going to skip it. Then let's give it a name. We'll call it price feed, since this aggregator v3 interface is going to be giving us a price feed. Then we can do equals, and this is where we're going to initialize the contract. So how do we actually choose where to interact with this contract? Well, we just type aggregator v3 interface, and then we put in here the address of where this contract is located. In order to find where this ETHUSD price feed contract is located on the RinkB chain, we can look at the Ethereum price feeds Chainlink documentation. It has a ton of different price feeds and even more not price-related data. Let's scroll down to RinkB because, again, on each different chain, the contract address that has all this price feed information is going to be different. Let's scroll down and find FUSD, which is right here. And we'll copy it and we'll paste it into here. Now, what is this line saying? It's saying that we have a contract that has these functions defined in the interface located at this address. If that's true, then we should be able to call pricefeed dot version. And we should be able to return it. Whoops, looks like we forgot to add those here. And we need a semicolon here. Hit Control S or Command S, compiles. It looks like we're compiling successfully. And we do need to deploy this on a testnet. Remember, this address here is located on an actual testnet. It's located on an actual network. It's not going to be located on our simulated chain here. So we do need to deploy this to injected Web3. We do need to deploy our contract to Rinkeby because the Rinkeby chain has this address. We'll learn later on how we actually can work with a simulated chain and work with these price feeds, but that's much later in.
This is something I haven't seen before. This contract may be abstract, not implement an abstract parent's methods completely or not invoke an inherited contracts constructor correctly. Oh, that is because we chose the wrong contract here. We were trying to deploy the interface directly to the network. Adoy. Alright, so when you're deploying to a test net or even the main net, you need to use your browser extension wallet in order to inject it into Web3, right? So when you deploy here, you're going to get asked by MetaMask to confirm the contract deployment. It's going to tell you how much gas you have to pay, et cetera, et cetera, et cetera. So I'm just going to go OK. And then we're going to pull it up on Etherscan because this is always cool. And we're waiting for it to be confirmed. You can see here we got transaction 3 confirmed. That should all be good. You can see we got our check mark here indicating that the transaction was complete. And now we should be able to click the get version button, and I expect it will return the current USD price of Ethereum. Hujat. 4. Buy the dip, boys. Fucking 4. What went wrong? Let's see what happens.
Of course. So let's go ahead and save. We'll deploy. Make sure we're on injected Web3. Now we can go ahead and hit deploy. MetaMask is going to pop up per usual. Confirm. We're going to get a transaction link to Etherscan showing us our contract. And once it actually is confirmed, we can see we have our contract right here. Now we have our familiar functions with one additional function. We have our fund button, which is red because it's payable. We have our address to amount funded mapping, which is blue because it's a view. And we also have this get version button that's also blue. If we go ahead and click it, we can see that the version of our aggregator v3 interface is version 3.
Okay.
This is the third version of the aggregator interfaces. Hence the name.
It wasn't
aggregator
actually
v3
the
interface.
I understand.
So we just made a contract call.
I was expecting this to give me that feed, obviously, right? But that isn't what we're being given. We're gonna want to call decimals. No. Probably get latest round data. Mm-hmm. Mm-hmm. Okay, so let's see if we can do it without him telling me. Uh, is it get round data? Why is get latest round data not an option? Oh, because it's get round data or latest round data. Understood, understood. So if we go latest round data, right, because latest round data is returning a whole bunch of stuff, and we just want answer, so maybe, hmm, expected comma, got identifier. I don't remember how to restrict the data being returned from that function. Guess we
To
continue
another
on.
contract from our contract using an interface. This is why interfaces are so powerful, because they're a minimalistic view into another contract. So this is great. We have a get version function, but this still isn't the function that we want. We want to call the get price function, which, if we look at our interface, we can see there's a latest round data function that returns an answer. This is the function that we're going to want to call.
Well, it's worth noting that it's an int 256.
On this contract. So let's go ahead and make a function that calls that instead. So we're going to do function get price public view returns uint 256. Uh-oh. This latest round data function, though, returns 5 variables. So how do we actually work with that? Well, let's find out. To work with this contract, we're going to do the exact same thing. We're going to do aggregator v3 interface, because this is the type of the contract. Price feed equals aggregator v3 interface. We'll do this same address in here, because this is the ETH-USD address. Then we'll do price feed dot latest round data. Now, since this is going to return 5 different values, we can actually have our contract also return these 5 different values. We can copy paste like this and literally do this, these 5 values.
Okay, what? Man, I wish this guy had a bigger fucking monitor. Like, why can I not see his whole line of code?
Equal price feed dot latest round data.
Goddamn nightmare.
And you can see that even compiles correctly. Let's adjust the formatting a little bit here so it looks a little bit nicer. A tuple is a list of
Yeah, fuck off with your tuples.
We can actually have our contract also return these 5 different values. We can copy paste like this and literally do this.
Okay.
These 5 values equal price feed dot latest round data. And you can see that even compiles correctly. Let's adjust the formatting a little bit here so it looks a little bit nicer. A tuple is a list of objects of potentially different types. This is the syntax for getting a tuple. We can define several variables inside one of these tuples. Although our compiler is going to give us some warnings. It's saying unused local variable because we're not actually using these for anything. We'll come back to this. Now we can go ahead and do return, and we can pick one of these variables that we want to return. Answer is going to be the price. So we're going to do return answer. But we're going to run into an error. Return type argument int 256 is not implicitly convertible to expected type. Answer is an int 256, and we want to return a uint 256. So how do we rectify this? We can fix this by using what's called typecasting. If we just return answer, we're going to be returning the wrong type. However, integers.
Okay, so it kind of just blazes past this. So what this tuple is actually doing is it's defining all of these as variables within your function and assigning them to the data feed that's being given to this function here, right? So this interface is providing all of this data from that linkage, and you're basically saying, all right, create a variable that's named this and link it to the first data feed from this function. Take the second variable of this type and link it to the second data feed provided by this function in this interface, right? Um, and then from there, you're just saying return whichever variable you want. And now we're going to do a conversion from the uint that this is configured to. I don't know why we can't just make this an int 256 to get the answer, but we're going to go through a conversion of that now, I guess.
And Solidity are really easy to cast into each other. So we can just do uint 256 and wrap it around this answer, and then compile and save that instead. As you can see, now our compiler is happy because we've
all right, let's wrap it.
changed.
I think this would be sufficient to deploy. Ta-da. Now I would expect this to be the current market price of ETH. Damn, I gotta check my wallet. So I think he explains it a couple times as well, but this is including 8 decimal places or something, right? So it's 3,059 USD uh, and this number cents.
This answer into a UINT 256. Awesome. So now this get price should return the latest price of Ethereum in terms of USD. Let's go ahead and deploy this new contract with this new function. So same thing, we're going to come to our deploy section, hit the deploy button. Oh, remember, we got to go to the fundme.sol.
I made
Let's
that
deploy
mistake.
it. Confirm with MetaMask here. And let's scroll down to our newly deployed contract. As you can see, we have our get version function, which still works exactly the same, but we have a new function too, called get price. And this should return a UINT 256 answer. Let's go ahead and click it. Amazing! We've actually returned an answer. Now, again,
when was this made? 5 months ago. Look at that price. Wish I got in at 2,400.
You're a little confused on why this number looks so big. You have to remember that this actually has 8 decimals. We could call this decimals function on the contract to learn that. 1, 2, 3, 4, 5, 6, 7, 8. And we know that the current price of Ethereum in terms of USD is 2,482. Awesome. So now that we have the price, we can actually get the conversion rate. But let's clean up this function a little bit before we go on up there. As you can see, one thing that the compiler is complaining about is we have a lot of unused local variables. But latest round data returns 5 different variables.
So what he's going to suggest we do is we're able to just have blank fields here that basically says ignore the first data link, populate the second data link with the answer, ignore the third, ignore the fourth, etc. And all you really have to do is leave these blank fields here. I don't think spaces are required, but there we go, all done. What's this? Gas requirement of function fundme.getPrice is infinite. That's good to know. I hope he teaches us
how
do
we actually
not make it cost infinite gas,
but make our compiler happy with us? Well, we can actually just return blanks for each one of these sections with commas in between each other to say, hey, there is a variable here, but we're not going to use it. This will also make our code look a lot cleaner because now this function's a lot smaller. We say, something's here, we're ignoring it. In 256 answer, we're going to use something's here, ignore it, something here, ignore it, and ignore this too. And we can even test this out by compiling it, deploying it, checking on RinkB, scrolling down, hitting this, and hitting get price. And you can see, indeed, it's the exact same as before. Awesome. So now we're all done cleaning things up, right? Not quite yet. See, the other thing that's really annoying here, we have this massive chunk of code at the top that is probably a little redundant. There's a good chance that a lot of our contracts are going to want to use this aggregator v3 interface. So let's just go ahead and add that at chainlink/contract syntax backend, because it's going to look a lot cleaner here. And do at chainlink/contracts. If you ever get a little bit confused with what you should be importing to work with their contracts, we can see right in the documentation at the top, this at syntax is what this is going to use. Now you can also go ahead and browse that npm package of at chainlink/contracts to see what other applications are in there and what other files are in there, or you can just peruse around the GitHub. Now the third way we can actually do imports is we can import from contracts that are in the same file system as our contracts. Well, awesome. Our contract is starting to look more and more put together. Now, one other thing that I usually like to do with these is I usually like to put everything into the GUI way standard. So as we saw, this get price had 8 decimal places. However, the smallest unit of measure, aka way, if we look at it, has 18. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8. So typically in these, I like to try to make everything have 18 decimals as well. You don't have to do this, and it'll save some gas if you don't, but I usually like to multiply everything so that everything has 18
decimal places. It's going to save gas if I don't.
So since I know this has 8,
will not.
I can just do 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And now this will return the price with 18 decimal places instead of 10. Now we have the price of Ethereum in US dollar, which is fantastic. So we could set the price of our funding function to anything that we want here. For example, let's say $50. We could convert whatever value that they send us to its US dollar equivalent and see if it's greater than or less than $50. All we have to do is make a new function that converts that value that they send to its US dollar equivalent. So we could do function get conversion rate, and it'll take a UINT 256 eth amount. Let's get this out of the way for the rest of this. It'll be a public view function, since again, we're not actually going to have it make any state change. We'll do returns, UINT 256, and then in this function, we can do UINT 256 eth price equals get price. And we can call this get price function up here. Now we have the price in here. What we want to do is we want to convert whatever value that they send as eth amount. Let's say they send 1 GUI, or again, that's going to be this much GUI. How do we convert this to ETHUSD? Well, we can now do UINT 256 eth amount in USD equals this eth price times the eth amount that they sent. This is actually going to result in a much bigger number than we're looking for. And then, of course, we're going to return it. Let's test this out and see why we have to do one more thing here.
Okay, so let's see what was done. Function get conversion rate, it takes a UINT 256, which is the amount of Ethereum. Okay. Now we're equating the UINT 256 eth price to the get price function, which is just returning the Ethereum price in USD. So the eth amount in USD is the amount submitted to the get conversion rate function times the current Ethereum price in USD. All makes sense, all pretty self-explanatory there. And then we want return eth amount in USD. What? Why are you yelling at me now? Oh, it's because we didn't put a semicolon up there. public, so public view, that should make this a field that we can enter into when we deploy the contract. So let's just see how she works. Deploy. Gonna cost us fucking money every time now. Fake money. Come on, validators. Ain't nobody got time for this shit. Alright, so yeah, let's say I have. Ooh, UNT 256 is whole numbers, isn't it? Like, it doesn't take decimals. What happens if I put 1.4 Ethereum? Error. Okay. So if I put 6 Ethereum, I said, goddamn. 1, 2, I don't know how much this actually is. 2, 3, 4, 5, 6, 7, 8. So 18,357, which we would assume to be 6 times 3,059. So math seems to check out. Oh, we've deleted everything. Math seems to check out. Hooray.
Let's test this out and see why we have to do one more thing here. So let's, again, fund me. We'll deploy, rank B. We'll scroll down, and we have this new function called get conversion rate. Let's grab this 1 gwei and put it in here. Whoa, this seems like it's a really big number. We're saying that 1 gwei is equal to 1, 2, 3, 4, 5, 6, 7, 8, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This many dollars. Now, I don't know about you, but I don't think the price of even 1 Ethereum is that many dollars. Maybe in the distant future, but definitely not right now. The reason that it's off is we have to then actually divide by this number. The reason that we have to do this is because both ETH price and ETH amount have an additional 10 raised to the 18th tacked onto them. So now we have to divide it out in order to get the right number.
So let's take a moment briefly to appreciate the fact that that was only the case as a product of his faffing about up here, where he added this factor of 10 to convert it into way. Like, if he had just not done this, he would have gotten the same answer we got, right? It would have just been fine, because only one of the values being fed into this function would have had 18 decimal places. Yeah, so that, I, I disagree with what he's done here. I understand he wants to keep everything on the same like conversion level, but it costs more gas, and it makes you have to cost more gas later in order to adjust that conversion. It doesn't seem like it's worthwhile to me. Just leave it in Ethereum, have them submit whole values of Ethereum, or it would be nice just to be able to submit fractional values. So we're eventually going to switch this uint 256 to, I don't know, floating point something.
So we're going to compile, deploy, confirm. We're going to scroll down. And now let's try this 1 gwei. We'll get the conversion right here. And we can see we get a number that makes a little bit more sense. Now remember, this has 18 decimals as well. So the real number is 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And we know that this number is actually accurate because we can go ahead and pull up a calculator, pop that into here, and we know that this is 1 gwei in US dollar. If we get the conversion rate, we're saying that this many gwei equals 1 ETH. So we can check it back by multiplying this number by that, and we see that we do actually get the price of.
It's just, why would you do that? Like, I mean, if it is ever meant to be some sort of like donation platform, no one is ever going to submit their donations in fucking gwei, right? Like, you just need to allow them to submit fractional floating points of ETH.
1 Ethereum in US dollar. So our math here checks out. Awesome. Now, since we're on the topic of math, I do want to talk briefly about some of the pitfalls of Solidity, especially when it comes to math. Prior to Solidity 0.8, if you added to the maximum size a uint number could be, it would actually wrap around to the lowest number that it would be. And in fact, you can even demo this with a contract here. Now, you don't have to follow along with this contract, but just watch to see the example. We're going to call this overflow.sol. Now in here, we're going to add all kind of the normal stuff, contract, overflow, and we're going to add a function called overflow. We'll make a public view, and we'll have it return a uint 8. I'll show you why in just a minute. A uint 256 is a really, really big number, and it's hard to kind of imagine going over the maximum cap of a uint 256. But a uint 8 is a lot smaller, with the maximum number actually being 255. So if we create a uint 8 and we call it big equals 255, and then we just do return big, what do we think we're going to get here? For this, we can go ahead and use JavaScript VM because we're not interacting with any other contracts. Let's deploy this.
Not return 255.
We'll see in our contract, if we call overflow now, we're just going to get 255.
Right.
However, what happens if we add 1 to this
just
number, or try to add
me?
1 to this number? If we do it just like this, Solidity actually knows that there's an issue here and says, hey, try not to do this. But if we typecast this as a uint 8, Solidity gets a little bit more confused and goes ahead and lets us do this. Now, what do we think big is going to be?
0.
It should be 256,
or
right?
1. 0 or
but
1.
Big is a uint 8, and this is the maximum size that it could be. So what happens when we deploy this? We look down.
0.
We actually get 0. What happens if we do 100 and we deploy that? We actually get 99. And this is because integers can actually wrap around once you reach their maximum cap. They basically reset. This is something we need to watch out for when working with Solidity. If we're doing multiplication on really big numbers, we can accidentally pass this cap. Luckily, as of version 0.8 of Solidity, it actually checks for overflow, and it defaults to check for overflow to increase readability of code, even if it comes a slight increase of gas costs. You can use this unchecked if you want to have it keep that wrapping functionality. So just be aware, if you're using a lower version than 0.8, you're going to have to do something to make up for this. And we could write a whole bunch of code here basically to check all of our math, or we could just import something called SafeMath from another package. Similar to how we imported Chainlink, we can go ahead and import a package called SafeMath from a tool called OpenZeppelin. Now, OpenZeppelin is an open source tool that allows us to use a lot of already pre-built contracts. We can go ahead to their documentation and go to their utilities and see SafeMath. And they even have a little sticker here saying, SafeMath is no longer needed, started with Solidity 0.8. SafeMath is a tool and a way for us to avoid some of these problems with doing math in Solidity. Now, I'm not going to spend too much time on the contracts that actually fix this, but we can actually import right from the Chainlink directory as well a Solidity file called SafeMath Chainlink. And what we can do is right after our contract, we can do using SafeMath Chainlink for uint 256. And what this will do is it'll use SafeMath Chainlink for all of our uint 256. And SafeMath Chainlink doesn't allow for that overflow to occur. Libraries are really similar to contracts, except that they're isolated code that can be run in a reusable safe math chain. It'll use safe math you went to safe math chain, a Solidity file called safe math chainlink. And what we can do is right after our contract, we can do using safe math chainlink for uint 256. And what this will do for uint 256. And what this will do is it'll use safe math chainlink for all of our uint 256. And safe math chainlink doesn't allow for that overflow to occur. Libraries are really similar to contracts, except that they're isolated code that can be run in a reusable context. In this case, we're attaching the safe math chainlink library to uint 256 so that these overflows are automatically checked for. Just keep in mind, if you're using anything less than 0.8, you're going to want to use some type of safe math just to check for your overflows. Now, this is for those of you who are familiar with safe math and integer overflows and underflows. We are not going to be calling the functions that safe math provides us, like div, add, mul, all those functions. Simply because in 0.8 moving forward, we no longer have to use those, and we can just use our regular operators like plus and minus. So this is great. Our contract is coming along really well. We now have a way to get the conversion rate of whatever F is sent and turn it into US dollar. Now we can set a threshold in terms of US dollar. But how do we guarantee that whatever amount that the users send when they call fund is going to be at least $50? Well, first we might want to set a minimum value. So we can do uint 256 minimum USD equals, let's say, $50.
Of course, it's got to be $69.
And again, since we're using everything in GUI terms, we want to then multiply this by 10 raised to the 18th.
No.
And just wanted to take a pause for a second because this line is actually wrong. This should be raised to the 18th. So this line should really look like this, where it has the double star. So apologies, the rest of this has that single star, but it should be the double star here. If you do have the single star, though, the rest of the contract will still work fine. So this will be the minimum value. It'll be $50 times 10 raised to the 18th so that everything has 18 decimals. Now that we have a minimum amount, how do we actually make sure that this minimum amount is met in the value that they send us? Well, if you're familiar with if statements, we could do something like if message.value is less than minimum USD, then revert, or we could do something a lot easier and better practice and much cleaner. We could do what's called a require statement. When a function call reaches a require statement, it'll check the truthiness of whatever require you've asked. So in our case,
it will check the truthiness. Why can't people just use words that exist already?
Converted rate of message.value needs to be greater than or equal to our minimum USD. This line says that if the conversion rate of message.value to USD, if they didn't send us enough ether, then we are going to stop executing. We're going to kick it out. We're going to say, hey, this doesn't count, and we're going to do what's called a revert. We're going to revert the transaction. This means that the user is going to get their money back as well as any unspent gas. And this is highly recommended. We can also then additionally add a revert error message. Something like, you need to spend more ETH. So now let's try this out. As we saw, one GUI is going to be way less than $50. So if we send one GUI along with this fund contract call, it should kick out and say,
Yes, I did mean minimum USD. . Um, Alright, so presumably, if I click fund now, it is going to fail, and it should tell me that I need to spend more. That's what I expect to happen. Go. Confirm. I mean, that seemed to work. I don't know what to say. Hmm. I mean, it seemed to go through. Why did my limit not work? Require. Hmm.
You
Maybe
need
we
to spend more ETH.
jumped ahead somewhere.
So let's actually try this. Let's go to the deploy tab. We'll get rid of our overflow. We use injected Web3 because, again, we are working with the Chainlink aggregator contracts that are on chain. We're going to move to fund me, and we're going to hit deploy. MetaMask is going to pop up, and we're going to hit confirm. Now, if I try to hit fund, let's see what happens. We're getting a gas estimation failed. It says gas estimation error failed with the following message. Execution reverted. You need to spend more ETH. So the contract isn't even letting us make the transaction. We can go ahead and try to send the transaction, but here's what's going to happen. On ETH.
So this is the difference. I had entered a value of 1 here. Like, what happens if we try to fund this with no value? You need to spend more. Okay. Transaction failed. Still indexing. I wonder if this will also give me the error somewhere. Yeah, it does. Fail with error. You need to spend more. Okay. Execution reverted. So why did one GUI work then? That's strange to me. What happens if we have one way? This one seemed to work. Doesn't seem to make sense to me.
Ether scan, once this goes through, you can see that once this transaction finished, we got this status, fail with error. We need to spend more ETH. We don't want to force these transactions to go through. If we look in our MetaMask, we can even see this failed bit here. So whenever you see these gas estimation failed errors, usually that means something
It has something to do with this conversion that I'm misunderstanding, I think.
reverted, or you didn't do something that was required. However, if we go to value here and we spend a lot more, let's say zero 0.1 Ether, which if we take out our calculator, 2500 times 0.1 is going to be $250. This should easily be well and beyond past our $50 threshold. So let's add 0.1 Ether. Now remember, we got 0.1 by adding it in the converter and grabbing the way. Again,
Okay, so at 30, 59 times okay, so 0.01 ETH should be insufficient. It's only going to give me whole values. So this should be equal to $30 USD. And it just seemed to be fine. I'm not sure. All right, let's see if this works. So I would expect this now to be insufficient. Hmm. Wait, what? Oh, there's two transactions. I understand. Reject, reject. So 70 way works without issues. What if we make this 4? Now I don't understand at all. That doesn't make a lot of sense to me, I'm afraid.
The way is the smallest denomination. Now, if we change this to way and hit fund, this should go through. We go and hit fund now. You'll see MetaMask pops up because MetaMask goes, oh yeah, this transaction isn't going to revert. And that's what we want. So we can go ahead and hit confirm. And now we'll finally have sent some funding to our contract. Now that this is confirmed, we can go ahead and grab our address here, pop it into our address to amount, and we can see that indeed our funding has gone through. Now we can be part of this crowdsourcing application with our minimum value, which is fantastic.
Okay, so what this has effectively done is we can now have a wallet interact to submit funding to the contract, and then this will tell you how much a given address has submitted to the contract. So I expect if we go another 1,000 and hit fund, wait for the transaction to complete, I expect that now this is going to say 70,000, and it does. So okay, so that's pretty interesting.
Awesome, great job. Awesome, so now we can fund this contract with a certain minimum USD value. In this case, it's going to be $50. Now, you'll notice though that right now we don't do anything with this money. So we're going to fund this contract. However, that's it. And we don't have a function in here to actually withdraw the money. So there's no way that even though we just sent this contract some money, there's no way for us to get it back. So how do we fix this? Well, we can add a withdraw function in here. So let's go ahead and add that. Function, withdraw. And this is also going to be a payable function because we're going to be transferring ETH. We'll make this public. And we can do message.sender.transfer. Transfer is a function that we can call on any address to send ETH from one address to another. This transfer function sends some amount of Ethereum to whoever it's being called on. In this case, we're transferring Ethereum to message.sender. So all we need to do now is define how much we want to send. Well, we're going to send all the money that's been funded. So to get all the money that's been funded in this contract, we can do address this dot balance. Now, there's a couple of special things going on with this line. First, we're saying address of this. This is a keyword in Solidity. Whenever you refer to this, you're talking about the contract that you're currently in. And when we add address of this, we're saying we want the address of the contract that we're currently in. Whenever you call an address and then the balance attribute, you can see the balance in Ether of a contract. So with this line, we're saying whoever called the withdraw function, because whoever calls the function is going to be the message.sender, transfer them all of our money. So let's go ahead and try this. Let's deploy FundMe.
What a ridiculous contract.
And now let's fund
Anyone
this
who interacts with this contract can withdraw all of the money.
We'll fund it with one whole Ether so that we can see it go into the contract and get pulled out of the contract. We'll hit the fund button and you'll see we're sending one whole Ether into this contract.
This bougie
now,
asshole.
If we
Your
look at our
faucet
balance,
gives us 0.1.
it's gotten down from 17 to 16. Or if you're still at 18, it went down from 18. So let's try to get it back. If we call this withdraw function now, confirm.
He has so much test ETH because his Rinkeby faucet that he used allowed him to take 18. This faucet that I had to use is obviously much less. For a reason, the Rinkeby faucet that he originally pointed us to is pretty much dry. It's like no funds available. Please fuck off. It's pretty disheartening.
Once this transaction goes through, we should get all of our Ether back. Let's look at our MetaMask, and boom, indeed, we have got all of our ETH back.
Okay, so let's see if we can get ours back. I mean, there's only 70,000. Oh, never mind. This is gone because this contract that I deployed is immutable, right? Like I have to get rid of this and then compile and send a new contract out, and then I can take and add as I see fit.
However, looking at this contract, we can see that, well, maybe we don't want anybody to be able to withdraw all the funds from this contract. That seems like it might be a really bad idea. Maybe we only want the funding admin to be able to withdraw funds. So how do we set this up in a way that only the contract owner can actually withdraw funds? Well, we learned before that the require function can actually stop contracts from executing unless some certain parameters are met. We can do the same thing here with require message.sender equals the owner. But we don't have an owner to this contract yet. So how do we get an owner to this contract the instant that we deploy it? Well, we could have a function called create owner. But what happens if somebody calls this function right after we deploy it? Well, then we wouldn't be the owner anymore. So we actually need a function to get called the instant we deploy this smart contract. And that's actually exactly what a constructor does. So typically, at the top of your smart contracts, you'll see a constructor. And this is a function that gets called the instant your contract gets deployed. We don't even need to do add function here. We can literally just call it constructor because it's what constructs the smart contract. So we'll make constructor public, and whatever we add in here will be immediately executed whenever we deploy this contract. So one thing that we could do is we could have an owner be set the instant we deploy the smart contract. So in the top, we could add address owner. And in our constructor, we could say owner equals message.sender. Because the sender of this message is going to be us. It's going to be whoever deploys this smart contract. We can even test this out in the JavaScript VM to be a little bit quicker because we're not actually going to be calling the fund or the get price function for now. Oops. Let's also make this public so that we can interact and see this owner variable. So now if we go to FundMe, we deploy this in the JavaScript VM, we should be able to see who the owner of this contract is. And it should be our address because this constructor function should have been immediately called the instant that we deployed the smart contract. Awesome. We can see the owner of this smart contract is indeed our wallet. Because remember, when we're working with the JavaScript VM, our wallet is these fake wallets that they kind of give us. We can even try this with an injected Web3, deploying this. And the owner should be this OX757, etc. address. Let's go ahead and look at FundMe, see the owner, and we do indeed see the owner is us. Okay, great. Now we have an owner. We can go down to our withdraw function and use that same require. So we can call require message.sender equals equals owner. Equals equals is the way that Solidity understands true false. We're saying that message.sender has to equal owner. Now let's go ahead and try this. And we'll try it with the JavaScript VM again for speed reasons. Let's deploy this FundMe. And if we go down here, we try to call the withdraw function. And it looks like it is successful because currently this is the address that deployed the contract and it's also the address that is calling withdraw. However, if we switch to a
What? The called function should be payable if you send value and the value you send should be less than your current balance. I can't even use get price. What the fuck's going on now? Actually, no, I remember. Get price I would expect not to work. And maybe fund isn't working for the same reason. What if I just commented this out? Transaction has been reverted to the initial state. Reason provided by the contract. You aren't the owner of this contract. Perfect. Seems to be exactly what we want. Now, if we go back here, looks like we paid gas to perform that. Go back here, we should be able to withdraw. Good. So yeah, this like require conversion rate thing is fucking me. We're just gonna keep that commented out for now.
Different account and call withdraw, you'll see that Remix actually freaks out down here. It says, uh-oh, something wrong happened. And this is essentially the require statement kicking out. If you want to try it with injected Web3 as well, we can absolutely do that too. And remember, the way to switch accounts in MetaMask is to either create account right here or just switch like this, and then we'll connect with account 2. So if I try to withdraw from this second account,
I mean, man, you know what I would do rather than just limiting the amount that they could put in? I would just give them options as to what to choose, right? Like this function fund, you would just make one that's function fund, and rather than message value, it would be $50, right? Like this is all you have to do. $50. None of this fucking message value bullshit. Just make them have $50. Um, there's argument to like leave it open to however much they want, but I would say that it is psychologically more enticing for people to. God, I've gone in. Oh, this has got to be message value. It's more enticing for them to have just options in front of them, right? Like you don't say, would you like to donate? How much would you like to donate? You say, would you like to donate $2, right? Oh my God, fuck. Okay, work is seriously bothering me again. This is fucking annoying. No semblance of work-life balance in this fucking company whatsoever. Uh, okay, where was I? Does it even matter? Is my train of thought completely derailed?
that didn't call the contract, and I hit withdraw now, it's going to give us gas estimation failed because the require statement is going to kick out. But again, if we switch back to account 1 and we call withdraw, MetaMask is going to pop up and it's going to allow us to withdraw. Now, obviously, there's nothing in this contract right now, so we're going to withdraw nothing, but we can still call it. It's going to do message.transfer 0. So this is great. We can now require this withdraw function is only callable by the owner. Now, what if we have a ton of contracts that want to use something like this? They require the message.sender to be some owner, or maybe it's more complicated than this. Is there an easier way to wrap our functions in some require or some other executable? Well, this is where modifiers come in. We can use a modifier to write in the definition of our function, add some parameter that allows it to only be called by our admin contract. Modifiers are used to change the behavior of functions in a declarative way. Let's create our first modifier. We'll call it modifier, which is a keyword, only owner, and we'll add this require statement in here. Require message.sender equals owner. Then, after this, we just add an underscore and a semicolon. What a modifier is going to do is it's going to say, hey, before you run this function, do this require statement first, and then wherever your underscore is in the modifier, run the rest of the code. So we could also do a modifier.
Say that again.
And we'll add this require statement in here. Require message.sender equals owner.
Good morning. Uh, this is just a basic funding smart contract. I'm learning Solidity.
Then, after this, we just add an underscore and a semicolon. What a modifier is going to do is it's going to say, hey,
It's uh, blockchain development for all intents and purposes. I'm making Ethereum or I'm making smart contracts for the Ethereum blockchain because I don't know, it's fun. I like learning this kind of stuff. Um, I am enticed by the idea of creating uh, community tokens. So I don't have a community. I'll never have a community, but I'm a member of a few communities, and think of it like a decentralization of the Twitch bit system. So uh, you can effectively just have this store of value, this community ecosystem currency that you could trade amongst a streamer community in whatever avenue they saw fit. And I think that's kind of neat. You can just have your own, would that I had a community, it would be the EQ coin, and I could use that to award people who participate in Discord or anything like that, right? And then maybe uh, letting my mind run, I was thinking you could use that community currency as a means to like auction off raffle tickets for giveaways, or you could sell. I come from flight sim stuff, so you could potentially have liveries that are turned into NFTs that you could then distribute to your community that way. Things like that. I know that there's a lot of pushback towards that kind of tech in the gaming industry these days, but um, I like the idea of taking the Twitch bit system, the control of that out of the hands of Twitch themselves. So that's kind of what I'm going towards.
before you run this function, do this require statement first, and then wherever your underscore is in the modifier, run the rest of the code. So we could also do a modifier where the underscore is up here, and then this is afterwards, but we want to run the require first. So now what we can do is we can make this function withdraw payable only owner public. And what's going to happen is before we do this transfer, we're actually going to check this modifier. We're actually going to run this require message.sender equals owner. And then, again, where this underscore is, that's where we'll add the rest of the function. So again, for speed reasons, and since we're not actually going to be interacting with the Chainlink data contract, we can go to JavaScript VM, switch to fundme, deploy, and we can call withdraw. Obviously, we can call withdraw from our account, but if we switch accounts and try to call withdraw, we're going to get an error, which is perfect, because that means our modifier is working correctly. Awesome. Now we have a fantastically succinct fundme contract here. The only thing that we're really missing is that when we withdraw from this contract, we're actually not updating our balances of people who funded this. So even after we withdraw, this is always going to be the same. So we need to go through all the funders in this mapping and reset their balances to 0. But how do we actually do that? We can't actually loop through all the keys.
Yes and no. So this guy says that we want to reset their balances to 0, but what if that wasn't your intent? Like um, you could potentially use this array, um, or you could use this value address to amount funded to populate an array, which then uh, could display just total amounts contributed to a pool. So let's say everyone in a community was trying to hit a threshold, right? Like uh, perhaps you're awarded X number of flight sim coins for time flown during community flights, and then eventually you held a contest where members of the community needed to donate these coins to hit a threshold in order to unlock something, right? I'm going to shave my head if you donate X number of coins. Uh, that would be a way for you to burn coins, fight inflation in the community, and it would be like a use case driving the community members to perform action or take action. Uh, I think that's useful, and omitting his next statement here, where you have to like reset those values to zero, would allow you to do that. It'd allow you to like track long-term contributions to a total. I think that would be a good idea.
And a mapping. When a mapping is initialized, every single key is essentially initialized. Now, we obviously can't go through every single possible key on the planet. However, what we can do is create another data structure, an array, something we're already familiar with. So let's go ahead and create a new funders array. That way we can loop through them and reset everyone's balance to zero. We'll do an address array because it's going to be an array of all the funders.
So like what he's literally going to do is create that array that I advised and then outline how we would reset them all to zero by looping them through. But you could just as easily not reset them and just have this array be callable by a function that says these people have contributed this much.
We'll make it public and we'll call it funders. Now, when somebody funds a contract, what we're going to do is we're going to do funders. Now, whenever a funder funds this contract, we can go ahead and push them onto our funders array.
What was that? Address array, public funders. Yeah.
So we can do funders.push message.sender. Now, if somebody funds multiple times, the funders array is going to be a little bit redundant, but we're going to ignore that for now. Now that we have an array of funders.
That's true. Like I wouldn't necessarily do this here, or I wonder how else you would do it. You would have to do it in the funding function, but you would enclose it within a check of the array, right? Like I don't know the exact syntax. I'm not clever enough, but it would be something like if funders again, no idea what the syntax is. Doesn't include message dot sender, etc. Now it would be if it doesn't include, then you would push it. I think in C# it allows you to go like then. Like there are different criteria. I don't remember what the syntax is again, but you can have multiple circumstances. So like if the funders does equal or does contain message.sender, you would then have to append message.value to that index, right? Like you would have to return the index that the funder exists in that array, and then add the message value to what was contributed to that total. So yeah, I guess we'll have to see how he implements it here.
When we withdraw everything, we're going to want to reset this to zero. When we withdraw everything, we want to reset everyone's balance in that mapping to 0. So we're going to do what's called a for loop. A for loop is a way to loop through a range of numbers to do something. So we're going to say for uint 256 funder index equals 0, because we want to start with the 0th index. We're going to give it a max size to go to. We're going to say the funder index has to be less than funders.length. .length is how we get the length of our array. And then we're going to say funders index plus plus. This means that we have an index variable called funder index, and it's going to start from 0. This loop is going to finish whenever funder index is greater than the length of the funders. Every time we finish a loop, we're going to add 1 to the funder index. That's what that funder index plus plus does. It adds 1 to the funder index. And every time whatever code is in this for loop executes, we're going to restart at the top. And all we're going to do in here is we're going to grab the address of the funder from our funders array. Funders. So the funder at the index in our funders array, we're going to use this as the key in our mapping. So we're going to take address.
Slow down, boy. Address. Okay, so this is basically just saying we're assigning funder to type address, and we're equating it to the index at the start of the for loop of the funders array that we've created. So the first time it goes through this, it's basically saying funder is equal to index 0 of the funders array. So every time you run the fund function, right? I deleted it here, but it was funders.push message.sender. Right. So each time the fund function is called, the person calling the function is added to the array. And then here, when we withdraw all of the funds from that address, it is going through each index, so each person that's been added to the list, assigning them one by one to this address, or I should say this variable, this address variable, and then we'll effectively be zeroing them out in the next steps.
Amount funded of funder, and we're going to set it equal to 0. So now our mapping is going to be all.
Now address to amount funded funder. So let me just refresh myself as to what that mapping is. Yeah, see, so we've got this mapping up here that basically maps a given address to a uint 256, and we've called it address to amount funded. So what that effectively allows us to do is tie a variable, a integer, a uint 256, to a address that's been provided. So like this message sender is an address that is being added to the funders array, wherever it went here. What? Where'd it go? Right here, address to the funders array. So this line is saying address to amount funded. Oh. So this line is saying use this mapping to assign this address's value to 0. funds. So if we were to deploy this, now we don't want to be the owner, so let's go here, and we're going to fund 2 Ether. Okay, so that's good. Ow. Now if I take this address, it shows that we've deposited 2 Ether, right? Now this funders array is also public, so I should be able to go like this to choose the 0th index, and it should display this same address. Good. Now if we try to withdraw using this wallet or this address, I assume we'll get an error. You aren't the owner of this contract. Good. Now if we go back here, this is the owner, right? We should be able to withdraw, and that has worked. And now if we check the address to amount value for this wallet, it should be 0 again. And it is. Perfect. Everything seems to be working there.
All updated to people having 0 funded in them. We do have to do one more thing as well. We have to reset our funder array as well. Now there's a couple ways to do this, but a really easy way is just to set funders equal to a new array. So we can do funders equals a new blank address array. So all right, it looks like we've got everything in here we need. Right away when we deploy this, we are set as the owner. We can allow anybody to fund whatever public good that we're doing. And they have to...
What did I do?
So we could do funders equals a new blank address array.
Okay, so unbelievable. So he got the same error that I fucking got.
Address array.
As you can see here. And then he corrected it and neglected to explain what the fuck he did wrong. Like, I have to assume this number, again, entirely an assumption, is setting the number of indexes, or like the length. It's setting the length of the array. Bad form. He should have explained that.
So all right, it looks like we've got everything in here we need. Right away when we deploy this, we are set as the owner. We can allow anybody to fund whatever public good that we're doing. And they have to fund it with the minimum USD value that we actually set. Whenever they fund, we'll keep track of how much they're funding and who's been funding us. We can get the price of the Ethereum that they send in the terms of USD. And we can convert it, check to see if they're sending us the right amount. We have our only owner modifier so that we're the only ones who can withdraw from the contract. And when we do withdraw everything from the contract, we reset all of the funders who have currently participated in our crowdsourcing application. Awesome! Let's see if everything works end to end. So we're going to go to Fund Me. We're going to deploy it. We're going to confirm from MetaMask. And remember, if you're ever confused about what's going on or something weird is happening in your transactions or your deployments, you can always go into Etherscan and read more about your transaction and what's going on. Now that
someone somewhere needs to do a more thorough tutorial of what the fuck you're looking at in Etherscan, because like just saying that like you can go here and check out all the stuff that's going on, like what does any of this even mean to the average person? Like, great. Right? Like, it's more or less self-explanatory from the perspective of what I'm doing, right? They're very simple transfers of funds. But, like, even these, if you were like, I wanted to look at this contract and just see what the heck it says. What the fuck is this? Sure, it may all be open source, but it might as well be in Greek to the average person, for sure. Like, all the government secrets could be widely expressed in just public forums, like on 4chan, if it was in a language no one else fucking spoke, right? Like, how open source is it really if it isn't user friendly? I think that's a consideration.
our transaction has been deployed, let's go ahead and just take inventory as what's going on. We have our owner, which is our address right here. We have the aggregator v3 interface version, which is version 3, which we can kind of ignore. We have the price of Ethereum in terms of USD with 18 decimals instead of 8. We have a function that allows us to get the conversion rate of any Ethereum amount to its US dollar equivalent. We have an array of funders, which right now starts out as empty. We have a mapping of addresses, which also right now starts out as empty. Let's go ahead and try to fund this contract. We'll use Way, just so that we're always on the same page, and we'll fund it with 0.1 Way. Remember, everything has 18 decimal places, so if we want to do 0.1, we just do 17. So we can do 1, 1, 2, 3, 4, 5, 6, 7, 8, 1, 2, 3, 4, 5, 6, 7, 8, 9. And that'll be 0.1 Ethereum. Now we can go ahead and hit fund, and we're going to send 0.1 ETH to this contract. Great. So if we look at the 0th index of funders, we can see that indeed we have funded this contract. Let's even have our second account fund this contract. So all we got to do is switch to this contract in MetaMask. We can go ahead and put 0.1 ETH back in here for value and hit fund. Now, as you can see, we're deploying. Go ahead. So all we got to do is switch to this contract in MetaMask. We can go ahead.
What he means is switch this account in MetaMask. We're not switching the contract at all. You're switching the account that's interfacing with the contract.
And put 0.1 ETH back in here for value and hit fund. Now, as you can see, we're deploying this from account 2. Let's go ahead and hit confirm. Funder at index 0 is going to be our admin, and the funder at index 1 is going to be our second account. And if we go ahead and we add this funder in here, we can see we've indeed sent 0.1 Ether with this account. If we go back to our account 1 and put this in here, we can see that that address also has 0.1 Ether. Fantastic. So let's try to be malicious. Let's try to have account number 2 actually withdraw all the funds in here. Let's hit this withdraw function. Uh-oh, the transaction has failed. We're relentlessly malicious. We want to send this transaction regardless. So even though I'm not the admin of this contract, I've gone ahead and still tried to send this withdraw. So what happens now? We can see that Remix is saying, hey, something went wrong. And again, if we look at Etherscan, we can see that there is a fail here. Since in our modifier, we didn't give a reason here, nothing shows up. But we could have always put a reason in there and something would show up.
It actually stopped giving me the ability to force the transaction, which is kind of interesting.
So, all right, let's go ahead back to the actual admin. And now let's try to withdraw everything. So if we hit withdraw now, we can go ahead and confirm. What should happen is everything in here should be back to 0, and this array should be back to 0 as well.
So presumably what we could do is let's send 95 ether. And then we're going to switch back to this one. We're going to withdraw. Hey, now we've got 2 accounts worth of ether in one account.
Well, and if we watch our address, we can see it literally just went from 0.4 to 0.6 because it got 0.1 from the original funding that this account put in and the 0.1 that our second account put in. So now, if we look at funder 0, we can see it actually errored because it is now a brand new array and there is nothing at index 0. If we try to see how much this address now is funded, it's back down to 0. Awesome! You've now learned how to deploy a relatively
I don't understand why my funder's call isn't that doesn't make a lot of sense to me. This array doesn't seem to be clearing off.
simple. It's nothing at index 0. If we try to see how much this address now array and there is nothing, we can see it actually errored because it is now a brand new array and there is no
Maybe it is possible that I didn't redeploy. Wow, my keyboard is an unmitigated pile of shit. Okay, fund. So this should be mine. Now if I withdraw, it should error. Excellent. Just as we expected. I must not have deployed after adding the line to reset the array values. Oh, boy. I need an AFK for like the washroom and stuff, so I'll be back. I'm back, and I've come bearing muffin.
Nothing at index 0. If we try to see how much this address now is funded, it's back down to 0. Awesome! You've now learned how to deploy a relatively simple yet effective crowdsourcing application where users can fund and an admin can withdraw those funds to go spend them on things. Now, we've been working with Remix so far to start our smart contract and our Solidity development journey. Remix is an incredibly powerful, what's known as a web IDE, or an integrated development environment. And in my opinion, Remix should always be the starting ground for anybody looking to start their smart contract journey, because it is a wonderfully friendly way to really show what's going on behind the scenes. And it's really easy to see everything we're doing with Ethereum, with Chainlink, and with our smart contracts. Now, it does have some limitations though. It's really hard to integrate other parts of different projects. It has some limited support for testing or custom deployments. It's a little tricky to save files locally. You need an internet connection to actually interact with it, and it doesn't have Python. So in order for us to deploy, test, and automate everything about our smart contract development cycle, we want to connect our Solidity and our smart contracts with a more traditional programming language like Python. This way, we can customize our entire development environment in any way that we like. We're first going to teach you all how to work with what's known as web3.py, which is an incredibly powerful Python package for doing everything that we want to do with smart contracts. Then, once we learn some of the basics of web3.py, then we'll move on to Brownie, which is a smart contract development framework built on top of web3.py, which makes our lives even easier. However, it's still really important to learn web3.py first, because this will teach you what's going on behind the scenes of Brownie. Now, for the rest of this course, I'm going to be working with Visual Studio Code, which is an incredibly powerful text editor that will give us a lot of formatting and a lot of really nice tools to work with deploying and interacting with our smart contracts. If you've already got VS Code and Python and your entire coding setup set up the way that you like it, feel free to use the timestamps in the description to skip ahead to the next section. You'll often hear people referring to this as VS Code or Visual Studio Code. But just to point out, this is not what you're looking for right in front of you here. Visual Studio is a different application. Make sure you're on Visual Studio Code. If you want to be a total hardo and just work with Vim or Emacs or whatever else you want to do, you absolutely can. But I'm going to go through setting up Visual Studio Code the way that I like it. And if you guys want to follow along, I highly recommend it because it's going to make your life a lot easier.
There's a link to download Visual Studio Code in the GitHub repository.
Basically, all you have to...
This guy's like secondary recording voiceovers. I wish he had some consistency with his mic quality. It's like he remembered he needed something, recorded it on his phone, and then added it to the recording or the video afterwards. All that to say, I think this is probably a good point for me to pause prior to transitioning my whole system over into VS Code. I've got VS Code all installed, and I've done a couple things in it already, but none of those things are the configuration of setup of Python. I haven't done any of that. Uh, and I think it's probably the least enjoyable part of Python. I get confused and overwhelmed trying to go through the fucking command to like pip install things. It's just not something I'm familiar with. So I want to take a few to go for a smoke, stretch my legs, that kind of thing. I've been sitting here coding for 2.5 hours now, so uh, let me see. I should have that sweet "be right back" sign. Oh man, I am a professional. Don't let anyone ever tell you otherwise. I also have a cat that is bugging me, so that's real cool. Whoa, whoa. Where's this cat? Where's this cat? Okay. Yeah, I'll be back. I'm gonna go for a smoke, stretch my legs, etc. I hope it shouldn't take longer than 15 or so. And then we will get into the exciting world of configuring VS Code for Python. Woo! I changed my mind. I'm going to cut the stream here in an effort to split this next Python Web 3.py stuff into a second video. So I will still be back 15 minutes or so, but I'm just going to cut the stream and then start it up again when I return. So I will be back.